Hello and welcome to the video on tests for parallelograms. This video is going to build very heavily off of a previous video just called parallelograms. So if you haven't watched that video yet, you might want to go and do that. In the video here today, we're going to be saying, what do I need to know about an object in order to say that it for sure is a parallelogram? So by the end of this video, you should be able to know a couple of different methods basically to show or prove that something is a parallelogram. Let's start with a few theorems and definitions. First of all, one way to prove something is a parallelogram is right off of what the definition of a parallelogram is. If you remember from the previous video, a parallelogram is a quadrilateral with opposite sides that are parallel to each other. So, if I can show a quadrilateral has each pair of opposite sides parallel to each other, then I would know that that quadrilateral is a parallelogram. So in this case, if I can show AB is parallel to DC, and that AD is parallel to BC, then I would know that figure ABCD is a parallelogram. Well, there's a few other ways to prove something is a parallelogram. Another way to prove something is a parallelogram is by showing that the opposite sides are congruent to each other. So if I can show that both pairs of opposite sides are congruent, then I know that that quadrilateral is a parallelogram. So in this case again, if I could show that AB is congruent to DC and that AD is congruent to BC, then figure ABCD is a parallelogram. Yet another way to show that something is a parallelogram, if I can show that both pairs of opposite angles are congruent to each other, that's enough to say something's a parallelogram. So in this case, if I can show that angle A is congruent to angle C, and angle D is congruent to angle B, then I know that ABCD is a parallelogram. Now both of those theorems should not have came as a surprise. If you remember back from the previous video, having opposite sides that are congruent and opposite angles are congruent are properties of parallelograms. So these are just two new ways to prove that something is a parallelogram. There are two others as well. So if I can show that the diagonals of a quadrilateral bisect each other, then that quadrilateral has to be a parallelogram. So in this case, if I draw in diagonal AC and diagonal BD and label that middle point E, if I could show that AE is congruent to EC and DE is congruent to EB, then ABCD is again a parallelogram. The fourth one here though was not a property we talked about on the last video. There is one more way to prove that something is a parallelogram, and it's if I can show that just one set of opposite sides are both parallel and congruent, then this quadrilateral would have to be a parallelogram. So in this case, I could do this with really either set of sides. I'm just going to pick one. Let's say I could show that AB is parallel to DC, and I could show that AB is congruent to DC, then that's enough to show that this is indeed a parallelogram. So let's try a few examples. Example number one, determine whether each quadrilateral is a parallelogram and justify your answer. When I look at number one, I notice that these two sides are congruent to each other, they're both 37, and these two lengths are both congruent to each other, they're both 15. So since I can show that opposite sides are congruent, that is a way to show that something is a parallelogram. For problem number two, if I look here, I notice that, well, one set of sides is congruent, they're both 37, and that same set of sides are both parallel to each other. So I'm showing here that one set of sides is both parallel and congruent. That was a way to prove something was a parallelogram, so my answer here is also yes. In problem number three, I have one set of sides here congruent to each other, and I have the other set of sides parallel. Now, of the 5 ways we just talked about to show that something is a parallelogram, having one set parallel and one set congruent is not one of those 5 methods, so the answer here would be no. Now I could explain that it wasn't one of those methods, or I could draw a counter example. I could have another object where one set of sides is parallel and one set of sides is congruent, and that thing is not a parallelogram, that's actually a trapezoid. Moving on, let's try some other examples. Example numbers 4 and 5, we're trying to figure out what x and y are so that each quadrilateral is a parallelogram. Well, in problem number 4, I notice here I have some angles. Well, if I can show that the opposite angles are congruent to each other, that's a way to show that something's a parallelogram. So for this thing to be a parallelogram, that 4x has to equal the 56. When I solve for x, I get x is 14. Now I can do the same thing with y. Again, opposite angles need to be congruent to each other. So the 4y plus 6 has to equal the 5y minus 24. To solve for y, I can subtract 4y from both sides, add the 24 to both sides, to get y is 30. Well, to plug that back in, 5 30s is 150, minus 24 is 126 degrees, just to make sure we got it right. And 4 30s is 120, plus 6 is again 126 degrees. Let's do the same thing for problem number 5. In this case, I notice here that I have some sides. One of the theorems, or one of the ways to prove that something is a parallelogram, is to show that the opposite sides are congruent. So the 3x plus 3 would have to equal the 5x minus 3. And then when I solve for x by subtracting 3x and adding my 3, I get x is 3. Plug it back in, 3 3s is 9, plus 3 is 12, and 5 3s is 15, minus 3 is again 12. So now we know we got that one right. Do the same thing with y. Opposite sides here need to be congruent as well, so the 4y minus 5 can equal to 2y plus 9. And again, just solve for y. When I subtract 2y from both sides, I get 2y minus 5 is equal to 9. And then add my 5 to both sides to get 2y is 14, which means y is 7 after I divide by 2. When I plug that back in, 4 times 7 is 28, minus 5 is 23, and 2 7s would be 14, plus 9 is again 23. We know we got that one right too. And one last problem here. We want to graph this quadrilateral with the given vertices and then determine whether it is a parallelogram. So problem number 6, point A is at 1 3, point B is at 7 4, point C is at 6 negative 2, and point D is at 0 negative 3. I want to figure out if this thing is indeed a parallelogram. Well, there are a bunch of different ways to do this. I could show that the opposite sides are parallel to each other. And that was by the definition of a parallelogram. I could show that the opposite sides are congruent. I could show that the diagonals bisect each other, or any of those ways that we talked about here. The method I'm going to show here today is using slope to show that something is parallel to each other. I can figure out if AB and DC are parallel by knowing the slopes of both of those lines. So if I find the slope of AB, remember the slope formula is the difference of your y's over the difference of your x's, or your y's over your run. So I get 4 minus 3 over 7 minus 1 to give me 1 over 6. I could then find the slope of DC as well. If I do that, I get a negative 3 minus a negative 2 over 0 minus 6. And when I do that, I get negative 1 over negative 6, which is again 1/6. Since I have shown that these two things have the same slope, I'm showing that they are indeed parallel. I now have one set of sides parallel to each other. I could then do the same thing with the other set of sides. We're going to do the same thing with AD and with BC. The slope of AD, well, that's a negative 3 minus 3 over 0 minus 1. Again, we were using A and D in this case. I get a negative 6 over negative 1, or 6 over 1. And the slope of BC. While using the ordered pairs B and C, I get a negative 2 minus 4 over 6 minus 7. And I get a negative 6 over a negative 1, which again is 6 over 1. So AD and BC are also parallel. Since I've shown both sets of opposite sides are parallel to each other, I can say that this thing is a parallelogram. This concludes the video for tests of parallelograms. I hope you have a wonderful day.